Alright my friends, so welcome to today's tutorial video right here. You have surely seen the Jet Culverin video, the giveaway video, so the last one. And you guys are here to know how to create this thing, okay? So I'm speaking about this move right here, okay? So it is pretty decent, of course. You can always improve your moves, okay? So effects wise, there is a lot of more stuff I could have done, okay? But I'm just here to show you how you can create those arms, okay? So that's basically the core purpose of this video right here. That's the reason why I'm gonna shift the focus on it as well. But yeah, so you guys want to start by creating two local scripts, okay? The first local script right here is gonna be responsible to detect your key inputs, okay? This basically means that it detects when you have pressed a certain key, and this event will lead to the move being created, okay? The second one is gonna replicate the move, okay? So the move's appearance. So let's say that those arms, for example, we would count them as the move's appearance, but also other types of effects, okay? And all these things are being created on the client, just to, you know, reduce lag on the server. That's the reason why we give the client that responsibility to do so, okay? And what basically happens is that once you've pressed a certain key, you're fire serving a remote event, and this fire server will lead to a reaction of the server script right here, and this server script will fire to all clients, okay, with this remote event, and this will lead to this replicate Jet Culverin script, so this replication script I've just talked about, to replicate the attack on each client, okay? That's just a short summary of what is happening, and let's take a deeper look inside of here. So we have a variable called UIS, which stands for user input service. UIS.inputBegin describes the event that an input has been done, okay? And in this case, we receive two arguments. The first one is the input which was done. The second one is GPE, aka game processed event, as you can see right here. And this game processed event tells us whether this input was done on purpose or not, or whether this input was done while interacting with in-game elements, okay? And I think that this is the better explanation of it, because through the GPE we can then conclude whether it was done on purpose or not. So if not GPE, so this basically means that if the player's input right here was not done, okay, while interacting with in-game elements, then this is gonna happen. And if this is the case, then we can conclude that the input was done on purpose, okay? Now we have another if statement right here which checks whether the input which was done is also the key we are looking for. So if input.keycode equals nmKeyCode q, so if the input was the q key, then we want a fire server, as you can see right here. Game get service replicated storage refers to this instance right here. Wait for child, okay, waits until this child right here is created, and then we fire server this remote event with the only argument called Jet Culverin, okay? Now if we take a look inside of the server script, you can see a bunch of lines right here. But let's do everything step by step. So what happens right here as well is that we are referring to this remote event, and then we have something called on server event, and this is an event which reacts to every fire server you do from a local script. And what happens is that we receive all of the arguments which are then being input with each fire server. In this case we only have one fire server for this whole game right here, and yeah, we basically know what kind of arguments we can expect, okay? So this right here is this what, okay? So what equals this one, and what tells us what to do, all right? Now the first argument right here, you guys might wonder, is not included in here, but it is being passed automatically with each fire server, and represents the player who has fire servered, all right? Now if what equals Jet Culverin, then this code right here is happening, okay? And this code, so we can categorize this by the following. This part right here is responsible to find an enemy you're trying to perform Jet Culverin on, okay? And if an enemy was found, that's basically what happens right here. Then we want to fire to all clients with the task to replicate the Jet Culverin, okay? And let me explain you step by step what I've done right here. So what happens is that we are defining a variable called ending point, which is nil, okay? Means empty, okay? For you guys, is empty at the beginning. And what happens now is that we are looping through the workspace, okay? And by looping through, I mean we are using get descendants, and what get descendants does is that it loops, literally loops to every instance there is inside of the workspace. So inside of these 3 folders, inside of this one, inside of this one, inside of all of these right here, including all of these, and so on. You guys hopefully understand what get descendants does. So we are able to detect anything inside of the workspace. Now, we are looking for a humanoid. Okay, that's the first requirement. The second one is that the parent of that humanoid is not our character. So why are we looking for these things? Okay, first of all, when there is a humanoid, we can conclude that there is a high chance of this humanoid belonging to an enemy, aka NPC whatsoever, or to a player's character model, okay? That's the first thing. And with the second requirement, we exclude that we have just targeted ourselves, so our character model, all right? Now, this third check right here compares the distance of our targeted enemy's humanoid root part's position and our humanoid root part's position. Basically, we have a potential enemy right here, and we are just comparing the distances, okay? And if the distance is not greater than 150 studs, then we are gonna, you know, make this target right here our enemy. What happens then is that this ending point variable receives a value which is the position of our enemy's humanoid root part, okay? And right here what happens is that coroutine resume, coroutine create makes the code right here, okay, these 2 lines run without interrupting the rest. As you can see, we have a wait for right here. If we would leave these coroutine things out, then this wait would just pause the whole script, okay, which is not the purpose. So we do not want the script to be paused at this point right here. That's the reason why we are trying to put this inside of a coroutine to make this code run inside of the background, okay, without interrupting the rest right here. So wait for, and after 4 seconds, once the enemy has been targeted whatsoever, we are gonna make the enemy take damage, okay? Yeah. And you guys might ask, okay, so why is there a delay of 4 seconds? This delay is because we expect the Jet Culverin to be done within those 4 seconds, okay? So this runs at the same time as the Jet Culverin replicates on each client. Now, after this was done, we are breaking this loop right here. So we are exiting this loop, means we are then being put right in, and we continue with the rest of the code. And if ending point is not nil, okay, so if there is an ending point, and you guys might ask, okay, why ending point? Ending point basically indicates that the Jet Culverin ends there, okay? And we can only determine an ending point when we have determined an enemy whose position we use as the ending point. That's the reason why I've called it ending point, just to make you guys understand. So if ending point is not nil, then we want to fire to all clients right here. With it has to replicate the Jet Culverin, and we are also passing the performer of this attack, which is the player who has fire serve at this remote event in the first place, and we are also passing the ending point, okay? So what is the task? P the performer, E the ending point. Now let's get inside of this replicate Jet Culverin script right here. What happens right here is that, wait, let me delete this because that's not up to date anymore. Wait, what happens when I do this? Ah, we don't even need that. Yeah, interesting. Let me quickly check if it works. So I've just deleted 2 lines. So I know that the first line doesn't do shit, but what about the second line? Let's see. Okay, seems fine. Seems fine, yeah. Alright, so let me quickly explain this part and then we are basically done. So we have a variable right here called ROX mod, which stands for ROX module. And as you can see, it requires a module script, which is inside of the replicated storage called GPO Shockwave. I've made a video on this ages ago, and this module script right here is just a GPO, rocks, shockwave, module script, which creates those rocks, shockwave, okay? That's just the purpose of this module script right here. I've made a tutorial on it. Check it out if you want to check it out. It is on my channel. But yeah, let's move on with this part right here. So we are referring to the remote event once again, .onClient event. So this is the opposite event of the onServer event. OnClient event happens when you fire a client, this remote event right here, which we are obviously doing at this point. So fire all clients. And we receive args as the only argument, but do not mistake this to be only one argument. Well, it technically is one argument, but it is a table which contains multiple pieces of information. That's the reason why you should not mistake it. But yeah, if arg.what equals replicate jet Culverin, so we are checking out the task. If the task is to replicate the jet Culverin, then we are doing a bunch of things right here, okay? And let's go through all of these step by step. So first thing is that we define a variable for our performer's character. C equals args.p, which is our performer.character, okay? Second thing right here is that we are looping through the character of our performer, and we make everything which has the name left hand, left upper arm, or left lower arm. So we make that we make those instances go invisible. So we set the transparency to 1. Okay, means this is responsible for making the performer's left, so the whole left arm, invisible. Right here we have 3 variables. The first one is called starting point, and this is the starting point of the jet Culverin. This is currently at our performer's left arm. Okay, the second one is called ending point, which is args.e. So you guys know about the ending point already. And this third one is called is called former points, and this is a table containing every point which the jet Culverin has passed so far. Okay, so let me explain the mechanism of how it works. So what basically happens is that we have a loop right here, as you can see, okay? And with each loop we are choosing a new point, a new location in our 3D world right here where the part should go to. Okay, let's say that the starting point, so the starting point is right here, okay? And as you guys know, it is a loop, means the next point then is going to be here, and then it is going to be here, and then it is going to be here, okay? And what the script basically does is that it creates a part for each point, and then makes the parts connect to each point, okay? So we have a connection of parts at the end, and that is what happens. So there's nothing more happening, and we have a table which contains all of the points which we have created so far, because it then calculates the parts position by adding each point to each other, okay, by summing them up, and then you've basically got your most recent point. Okay, but we'll get to this soon. So, and this is another check which checks if whether the ending points, so if the ending point is nil, then it returns, okay? So this is just an additional check right here, which is a bit unnecessary because we're already checking for the ending point on the server, which is the best thing you can do at this point. So I don't think that the client will do shit at this point. Well, yeah, we can just, yeah, leave it out. Then we have another function called total points, and this is a function which is responsible to get you the total amount of points, okay? And the total amount of points is basically your most recent point. It is a little bit difficult to explain when you have nothing really to show off, but let me try to do it. So as you can see, we are here in paint.net, okay? And let me draw a 3-dimensional system right here, yeah. Okay. So as you can see, wait, X, Y, Z. Nah, so let's say that this is your starting point, okay? So let's call this 1, 1, 0, 0. Okay, so this is your starting point, okay? Starting point A. Now, you have a loop which loops through for certain, for random amount, okay? And with each loop, a new point right here is being created somewhere in your in your 3D world right here. Okay, so let's do this. Let's do this. Let's do this. Okay. B, C, D. Okay, and what happens now is that with each point right here, we create parts. Okay, and each part starts somewhere and ends somewhere. And the starting point of the part is one point before the last one, and the ending point is the last point. Okay, and if you add A plus B plus C, you receive D. Okay, and that is what I was talking about. So that's the purpose of the total point script. By adding all of the former points together, you receive your most recent point. Okay, now let's take another look into this. So as you can see, local sum is an empty vector, and we're now having a loop which starts at 1 and ends at the total amount of points we have inside of that table minus 1. And minus 1 because of this. Okay, this is right at the beginning, and we do not want this to be inside of our total points calculation right here, because we have not really established this as a point yet. Although it is inside of our table, it only becomes a real point after we have created the part on it, another part on it, and have done all of the rest right here. Okay, but yeah, once this function is done, now wait, so this function just adds all of the vectors on this sum variable right here. So sum equals sum plus formal points to our table, and I as the index. And as you guys know, I starts at 1 and loops to the total amount of entries inside of the table minus 1. Okay, and then we return that sum variable at the end. And yeah, so we'll get to this function soon again, so when we are here inside of our loop. Okay, now we have something called SFX, so sound effects, script.getCulverin, clone. So we clone this one, parent it to the performance character, and then we make it play, and then we add it to the debris after 3 seconds. After 3 seconds, this thing is gone. And I've uploaded this myself, so I've cut it out on YouTube and pitched it down a little, and then I've uploaded it to Roblox. So I hope that this works for you guys. So the sound right here. Yeah, now let's get to the core part of this whole script, which is the loop. Okay, so for I 1 2 math random 10 to 20, so we are creating a loop which loops from 1 to a random number from 10 to 20. Okay, and with each loop we create a new entry inside of that formal points table, which contains a new point, a new random point, by using our performer's current position and then just adding some random numbers to it. Okay, so we have a range of minus 20 to 20 on the x-axis, from minus 10 to 10 on the y-axis, and minus 10 to minus 2 on the z-axis. Okay, just keep in mind this is basically left or right, so x left or right, y is up and down, z is in front or back. Okay, and putting a minus on the z makes the thing go in front, and making, oh no, I'm not sure on this one, but I'm sure on this one. Yeah, but just keep that in mind. Now what happens right here is that we are creating a new part inside of the workspace. Top and bottom surface is smooth, no outlines. The material is glass, the brick color is really red, and it is anchored. The size is 1.1.1 at the beginning, now 1,1,1, and can collide as faults. And the C-frame, now this is interesting. The C-frame is at our starting point plus the total amount of points. Okay, so when the loop begins for the first time, then starting point plus total points. Now this table is empty, and then when the loop starts, it receives 1 point in here. But as you guys know, minus 1 means it doesn't take this into the calculation of total points. Means this delivers 0. Okay, a starting point plus a vector with 0 still is the starting point. Okay, now wait, this was the wrong one, but yeah, nah, it still is the same. And so the first argument right here determines where this thing is located at, so where the part is located at. The second argument tells us where this part is rotated to. And as you can see, starting point plus total points plus former points. So basically this, as before, plus this one. Okay, and yeah, this one is basically the point where the part is gonna head to. Now, right here, I3, V3, so this is another loop, which loops through this folder called arms decals, and those are a bunch of decals which create that black shade on your arm, so that Buzo Haki shade, if you want to call it like that. And yeah, we're just looping through this folder and then just cloning everything inside of here, inside of our arm. Now we have a second arm right here. Nah, not a second arm, but we have a second port. Okay, and let me tell you what the purpose of the second port right here is. So as you can see, this is the second port right here. Wait, oh my god, this part right here. Nah, wait. This part right here, as you can see. Okay, so the second port is some kind of connector of 2 parts. Okay, so one port forms the arm and the other one forms the ankle, if you want to say. And yeah, it just connects both arms together and it just makes it look good overall. But yeah, and of course we want to clone all of the decals inside of that second arm as well, in that second port as well. And this part right here is where the magic happens. So we have a tween. Okay, and what a tween does is that it creates a transition from one state of an instance into the second one. Okay, so you can use this to fade out or fade in parts. Okay, so set the transparency to 1 or 0. But you can also use this for any other property you would like to edit. And in this case, we are using it for the size and for the C-frame, aka position. But yeah, let me explain what happens. So the instance we want to mess with is our arm, so X. Tween info are just a bunch of settings we have decided on. Okay, so the wait time, so 0.1, the easing style, the easing direction, and right here, so instead of that curly brackets, we have the states we want to achieve. Okay, so the goal properties we want to achieve on this fake arm right here. And as I've told you, this is where the magic happens. So the size is going to be 1 on the X, 1 on the Y, which is still the same as before. But now it is also going to be the length of our point. Okay, so former points bracket hashtag former points gets or indexes the most recent point. Okay, and our magnitude returns the length of it. So if you guys haven't had vectors in math yet, then this is a little bit tricky for you to understand, but understand this as the length of a vector. Okay, and the length then becomes our size. Now the C-frame right here, wait, let me try to emphasize this to you. Let's say we have another point called Q here. Okay, now this is 0 right here. All right, so from 0 to Q we have a certain length. Okay, and this is basically what this dot magnitude gets us. But now in our example, it isn't from 0 to Q, but it is from A to B. Okay, and also from B to C, and from C to D. Okay, now next thing, C-frame. So the C-frame is our current C-frame multiplied with another C-frame, which only moves on the z-axis, okay? And why only on the z-axis? So the thing is that we have already rotated the part, the fake arm, towards the point it has to head to. The only thing it has to do is to go forward, and the z-axis is known to do that, okay? So, and the thing is, when you try to size a part on Roblox, okay? So let's say you have a part right here, and you want to increase the size so that it stretches into this direction. Now, changing the Z value of your size, okay, does not only make the part stretch in front, but also into the other side. So you have a stretch on both sides. And what you want to do now is that you want to, so while moving it, but you also want to move it while sizing it, you also want to move it into the desired direction. So this happens when you size it, and you want to on top additionally move the C-frame into your desired direction, and this is what we are doing right here. So C-frame then becomes our current C-frame multiplied with another C-frame, which is the length of our point minus 1 and divided by 2. And why divided by 2? Because if we do not divide it by 2, then we have this whole length right here, okay? But if we divide it by 2, then we only have this one, and we want this part right here to disappear. So we do not want the brick to size towards this direction. That's the reason why we have to take this side and then move it into this one. And we can take the length of this side, or we know that the length of this side is 1.5 the whole one, okay? That's the reason why we do it. And then we make this tween play, okay? So this loop is basically just creating a new part. Wait. This loop is creating a new random point, okay, somewhere on the map, and it is creating a new part which is rotated towards that point, and then makes a tween move towards that point, increase the size towards the point, and it just does that over and over again, so that you have this illusion of a Jet Culverin move. All right. Now right here we have another quarantine, and what this part does is that it makes your camera shake. I don't want to go in depth on how this works, but we just manipulate the camera's offset within a loop. That's basically what happens, okay? So this was the main focus in my opinion. So explaining this part, just know that this shakes the camera. These parts right here, they're responsible for making the axe and axe 2, so the ankle and the arm, vanish, so transparency 1, within 2 seconds, okay? And once one tween right here is done, we can conclude that the other is done then as well, because both take only 2 seconds, and then we destroy both parts, okay? And in between each loop we wait 0.1 seconds, okay, which is also the same amount of time our tween right here takes to make this arm stretch into one direction. Now right here, yeah, so this is the loop, okay? The loop just loops over and over again. Now once this loop is done, once this loop is done, we are adding one more point to the ending to the formal points table, which is the ending point, okay? And now it is about creating the final arm, which moves towards the ending point. So yeah, we are referring to this rocks module right here, and then we are creating a new rock shockwave around the ending point. That's all you gotta know. If you want to know how to use this correctly, then just watch the video to it. Yeah, right here we are creating another arm, which then starts at the most recent point and is rotated towards the ending point, okay? By most recent point, I do not mean the ending point, but the point before, okay? Right here we are cloning all of the arm decals inside of that part, and then we have this tween right here, which then moves the arm towards the ending point. And right here I have, messed up this thing a little. So look, the problem is that those points up here are randomly selected. They do not try to to come near to the ending point, but they just randomly appear somewhere on the map, okay, nearby the player. And this last part right here is then gonna be the part which, you know, which snaps towards the ending point, okay? And I cannot really tell how far the last point or the point before the ending point is from the ending point itself. That's the reason why I've decided to increase the size on the z-axis to something pretty high, okay? So the default length of this vector multiplied with 4, okay? Because I don't really know whether the size is sufficient or not to reach the ending point, okay? And if you change this to multiplied with 4 on here, then you have to change it right here as well, okay? Then you want to make this play right here. We're just cloning the sound, so this explosion sound, and this explosion sound was made by me, so sorry for that. I've took it from the toolbox right here. As you can see, the sound disappears after 3 seconds as well. Then we have another coroutine right here, so it is the same thing as up here. So we have another camera manipulation right here. We are making this last arm vanish, and after the tween is done, we are destroying it. And after 0.1 seconds, so after this tween is done, we are making the arm right here reappear. And this is basically what happens, okay? So this is all about the Jet Culverin move I've created, guys. With that being said, thanks for watching. Leave a like, subscribe, share this video with all of your friends. Leave feedback in the comment section, guys. Take care and see you in the next video.